Right, so in this video I'm going to very quickly run through your energy revision and then you can do the polymer stuff yourself. So the first one, how can a student investigate if a reaction is endo or exothermic? And I've given you the reaction between a metal and an acid. First thing you need to remember is for these experiments, the greatest source of error is heat loss. So when you're doing this experiment, instead of using a beaker, okay, you are going to be using a polystyrene cup because it's a good insulator and it prevents heat loss. Okay, so what I've said is you place the acid in a polystyrene cup. Once you've got it in there, you are going to measure the initial temperature using the thermometer. Then you're going to add the metal to the acid. Now you're going to wait for the reaction to stop and you'll know it's finished because the fizzing will stop. We saw this week that when you react a metal and an acid, metal and acid is salt and hydrogen. Hydrogen is a gas. So when this reaction takes place, you see bubbles. And when the bubbles stop, that's when you know the reaction is complete. So when the reaction is complete, you're going to give the solution a bit of a stir, okay, to make sure that it's uniform and that the temperature is the same everywhere in the solution. And then you're going to measure the final temperature. Once you've done that, you can calculate the change in temperature. So you've got the initial, you've got the final, and if that temperature has increased, it's going to be an exothermic reaction, and decreased, it's going to be an endothermic reaction. Remember, even though my thermometer is actually in the reaction, it's still measuring the temperature of the surroundings. Okay, any temperature that you've got in degrees Celsius, regardless of where the thermometer is always measuring the temperature of the surroundings. So if the surroundings is increased, it's going to be an exothermic reaction. Decreased, it's going to be endo. The next thing, a reaction profile diagram for an endothermic reaction. Okay, so if this is what's going on in the surroundings, then what's going on within the chemicals themselves, all right? So if it's an endothermic reaction, we've written here that the temperature of the surroundings decreases. If the temperature has decreased, there's been a loss of energy from the surroundings. Where has that energy gone? Well, that energy has been absorbed by the chemicals and is now being stored as chemical energy in the chemical bonds. And that means if I look at the actual chemicals themselves, if they're absorbing energy, then the products should have more energy than the reactants. Okay, they've taken it from the surroundings have lost energy, lost heat, but the chemicals have gained energy, and that's what these reaction profile diagrams show. That shows what's happening from the point of view of the chemicals. They've gained energy, so now they should be higher in energy, so the product should be higher than the reactants. You always have to label the activation energy. It starts next to the reactants and goes the whole way to the top of the hill, so make sure you're starting that arrow right down next to the reactants and that you're labeling it. The abbreviation is E for energy, A for activation, or you can write the word activation energy. And then it's explain why it's endo in terms of bond making and bond breaking. Well, this is when we use bendo-mexo. Bendo, bond breaking is endothermic. Mexo, bond making is exothermic. Please just write that and nothing else. Marking your works, a few of you are writing breaking is an endothermic reaction. Don't say that. In any chemical reaction, there's endo and exothermic processes. So just don't contradict yourself and make it wrong. Keep it simple. Bond breaking is endothermic. Bond making is exothermic, and leave it at that. And then you have to explain overall why something will be endothermic. So if bond breaking is endothermic is when you put energy in. So let's say I have to put energy in to break those bonds, and let's say in total I'm putting 2,500 kilojoules of energy in. Exothermic, you're getting energy out. Energy is released when those bonds are made, and let's say if this is an endothermic reaction overall, I'm only going to get 2,000 out. So ultimately I need to put more in than I get out, and that's what makes it endothermic. So to phrase that in words, I'd say for an endothermic reaction, more energy is required to break the bonds. Okay, you have to put more energy in to break than is released when the bonds are formed. You have to put more energy in to break than you got out when the new bonds were formed. Those first two sentences will always be the same, and then this last sentence changes depending on whether it's endo or exo. If it was exo, you'd say more energy is released when bonds are made than is required to break the bonds, or something along those lines. But those questions always tend to come up, and they're usually 3 marks, so well worth practicing that and making sure that you've got your language correct.